Hello, we are back for some more videos. This is chapter 12, which is on regression. Section 12.1 gets us into inference for regression. I'm going to focus this video on just the conditions. There's more conditions with this and they're more complicated. So we're going to take time just to focus on those conditions. So there are 5 conditions, and a way to help you remember them is the word linear. So relationship is linear, observations are independent, residuals are normally distributed, residuals have equal standard deviations at each x, and data was produced randomly. Now the linear acronym that we're using is L, I, N, E, and R. So one way to help you remember them, but I know when I say those things you're probably thinking, so what does all that mean? Now there's this great figure in the book that is really helpful to understanding why we need all of them. So this is figure 12.6 from the book. And when you have your linear regression line, what we're trying to do is model this population true mean. We're trying to look at what really does exist, where alpha and beta are our parameters. We use our A and B to estimate that. So this is what we're shooting for, this is what we're looking for, and at each of those values we have a distribution about our x's, and those distributions should be normal. Now in order for all of this stuff to happen, well, our way of trying to see and trying to ensure it, so the regression model, when the conditions for inference are met, should look like all of this. So we're going to try all of our conditions and hope that that would help us to understand that it does look like that in the end. And that's all we can do. Our models aren't perfect, they're just what we use to try to create estimations. So our 5 conditions, why we need them, now how you're going to find them. So for the linear, you're going to look at the scatter plot and the residual plot and check for linearity. This is exactly as you did before when we did regression. So to show you a quick example as I work through these, I put some data into my calculator, nothing fancy, just stuff that I made up. So if I go to my lists, I have some data in there. Now I'm going to graph that. Remember we do scatter plot, so I'm going to turn on my plot 1. The first one is my scatter plot. I should have L1 against L2, and then I'm going to press zoom 9 to take me to my scatter plot. Now I can see that my data looks linear, but remember I always confirm that by looking at an R and R squared value. I can confirm that with my residuals, so I'm going to go to stat, calculate, and I always use 8 because it matches what our resource packet gives us for our equation. And I'm going to do L1, L2. And that gives me R and R squared. R is high, R squared is high, so both of those are helping me to say that I should be using a linear model. And one more time to check this, I'm going to turn off plot 1, and I'm going to turn on plot 2. Notice as soon as I did that, it popped up with L1 and resid there. So now I'm going to be looking at my residual plot. Zoom 9 again, and I see in my residual plot this nice scattering without a pattern. So based on that, I would say that we do have a linear model. Next thing we need to know is that we have independence. Now the independence is going to usually come from the context. Pay close attention to your context. Where did this data come from? If the data was already told to you to be independent, then you're off to a good start. And then remember, our other way of checking for independence is always a 10% condition. That will happen most in our studies. If you have a study, you want to check to see if there was replacement or not. If you're studying without replacement, then you need to check the 10% condition. Next, we need normally distributed. Now remember, what was normally distributed was those x values. We would be looking at normal distribution here. But we also need our residuals to be normally distributed. If our residual normally distributed, then we know that we missed in a normal fashion. So to do that, I can look at a histogram, a box plot, or a normal probability plot of my residuals. So I'm going to go back to my scatter plot. And instead of having a scatter plot, I'm instead going to look at, let's say we look at a box plot. And my list that I want to pull up is going to be my resid list. And then I'm going to do zoom 9 on that. And I'm looking for normal, although that looks to be over here a little. So for this data, this is making me wonder if it is normal, so I might want to then try a different one. And I could try zoom 9 here. And that's not looking to be very linear. So those two things would throw up red flags for me and make me wonder if this condition has not been met, in which case I would not want to proceed, or I shouldn't safely proceed with my procedures. Then equal standard deviations. Again, we're going to look at the residual plot. If you remember back to when we had our residual plot up, we're looking to see if our data is spread evenly. The distribution above is equal to the distribution below. So, sorry, zoom 9 to get back to that residual graph, and that's what I would want to be looking for. Now this one has kind of a funny pattern to it, but this probably wouldn't be too alarming. Things that really should stand out to you is when you see those sort of triangles happening. So if I see really close here and then it's spreading out that way, those are things that are red flags for me. Then we have random, and random again just comes from your context. Pay attention to the context and make sure that the data was gathered randomly. So lots of steps to go through, although they mostly are the same things that you would normally be doing for regression. Things that we're adding in here is looking at the the residuals being normally distributed, which is looking at the distribution of the residuals themselves. Then when you're looking at the residual plots like you would do anyway, you want to check to see this condition here with the equal standard deviations, meaning we're looking at the spread above and below. Hope this helped you to understand the conditions. I'll see you in the next video.